can always follow along on YouTube if you're not able to join the main Zoom session for any reason, or you want to go back and view it later. That is a good option. You can also apply the algorithmic thumb to the YouTube channel that will make it so that more people see it somehow. I don't know. It's a thing. So let's go back to the slides really quick. So hey everybody, I'm Will. I'm just giving you the old intro and telling you what we've got going on, kind of your MC for tonight. Welcome to slc.net. We've got a great guest here tonight to speak to us, and we'll try and get to his stuff just as soon as possible, but we want to spend a little bit of time today going back to something that we used to do. We did this a lot more when we met in person. We hadn't been doing it since we switched to doing most of our meetings on Zoom, but we're not sure why. We really like it and we wanted to do it. So we're going to bring back lightning talks today. So a lightning talk, for those of you who don't know, is pretty easy. It's a 0 to 5 minute talk about anything that you think would be interesting to this audience. Could be something new that you recently learned about, a particular feature in the newest version of C#. It could be something completely unrelated to .NET, but interesting to us because, as we were talking about before, we have hobbies, we have lives, right? So something you think would be interesting to this group. And we usually do this just by volunteer, which is a little funky, but we hope that you will be interested and that some of you will want to give lightning talks. As far as how that works, it's just raise your hand. I mean, if you're interested, unmute yourself and say hello, or put it in the chat if you like, whatever makes sense to you. And I, for my part, am very good at making it awkward. So I'm just going to be very quiet and I'll make it awkward. And when somebody speaks up and wants to give a lightning talk, then they can give a lightning talk. We won't sit here for the full 10 minutes, I don't think, if nobody's interested in giving one, but we might sit here for a minute. So I'm going to do it. I'm going to be quiet.
I have one, but I'll want to give other people a chance first.
Any takers? It's fun, we promise.
I would have one, but I want to hear what Steve has to say.
We have time for two, don't we?
Someone is saying John did raise his hand.
Oh, John.
John, unmute yourself. You can be a lightning talker.
John has the floor.
Can you unmute yourself, or do we have to do it? I hope I wasn't telling people to unmute themselves earlier and I couldn't do it.
Is there a John or is it a Jonah? It could be John A. Lewis. Did you raise your hand?
Oh, were you referring to me?
Yeah.
Did you raise your hand?
I didn't raise my hand.
You did not? Okay.
No. But I was kind of busy doing something when you were explaining what a lightning talk is. So explain it again, and I will do my best at giving.
Oh, well, we don't mean to put you on the spot, but if you're willing, you're welcome to. It's just, we set a timer. We let you talk for up to 5 minutes. If you end early, we might let people ask questions. It can be about anything. It can be about something to do with, the latest C# feature that you enjoyed or did something with that you hadn't used previously, or it could be about something completely different, right? It could be about a new ALM tool that you like, or it could be about, a new programming technique like mob programming, which we're going to learn about today. It could be anything, but we won't let you talk more than 5 minutes. That's the cutoff.
Dang, does it have to be? So I know you said it can be a little different,
Yeah,
but
totally.
I'm not a very technical person.
The idea is that it will be interesting to the group. That's all we're aiming for.
Ooh, all right. If you do this next time, I will do it. But right now, I'm not prepared for anything interesting to the group. because I'm more of
Okay.
like a fitness health type guy. That's all I really know personally. But I'll bring
Sounds
some
good.
next time though.
Cool. That works. Well, thank you. It looks like Gary's got his hand up. Gary, did you have a lightning talk you wanted to give?
Yeah, I could probably. Oh, let's see. Am I still on mute?
You're not now. We can hear you.
Oh, excellent. So I could probably give a quick one.
Okay. Let me start a timer for you. You're good to
And
go.
am I able to share a screen?
We can make you share screen. Yeah, you
just
bet.
say it. So let me just let me share a screen real quick so there'd be some code people can see.
Okay. Your time has started, just so you know.
Excellent. So I will be quick. So hopefully everybody can see that there's a little bit of code there. And I deal with an awful lot of legacy code if you haven't heard my talks before. And one of the issues that I end up doing on a lot of projects is being the first person to run static analysis on the code. And we use SonarQube. And one issue I ran into just this week was that we deal with forms over data and sometimes nullable fields. And so we end up sometimes with nullable Booleans, which there are a lot of ways to handle. There would be some more significant refactoring to go back and remove the nullable Booleans. But one of the issues I ran into, if you look at the comment on line 3, one way to deal with a nullable Boolean is to just use the null coalescing operator and say, well, some test question mark false. And so if some test is null, then in a conditional, then that conditional just returns false. The problem I ran into is that SonarQube flagged about 160 issues in one project I just started looking at, because that false inside the conditional is always false. One thing I could do is I could turn the check of that rule off, but then that's dangerous, because then if somebody comes along and does or some other condition that is also always false, then my rule's not getting checked, and I want to keep the rule checked. So there are a couple of ways to deal with this. In older versions of C#, I can use some test. So my actual Boolean value inside the conditional and say get value or default. And so then if some test is null, then false is what's returned. And then I'm using LinkPad so that I can just dump to check these values. In C#7, I can use the is operator. And the is operator is great because not only does it give me the ability to check whether or not this is actually a Boolean or whether it's nullable, I can put a variable here. So call this some var. Put this in an if. We'll take out the dump, or we'll move the dump down here. We'll add some brackets. And so some var is now a variable that's in scope of this block. Or if I just leave the underscore, that tells the compiler, well, the variable is required, but the underscore implies that I'm not ever going to use it. And so if I run these, now I get, in the first instance, it's false. In the second, it's true. In this one, it's true. In this middle one, it didn't dump the variable because some test is not a Boolean. And so the nice thing about this is now if I can use one of these techniques, change my conditionals to use either get value or default, or use the is bool, then I don't have to ignore the static checker test. And if somebody adds something to the conditional, then we'll catch it up later if that conditional is always true or always false. And that is the end of my talk.
Awesome. Thanks, Gary. Anybody have questions for Gary? We've got about 45 seconds left in his time. You can put them in the chat and we'll read them out, or we can move on. All right. Thank you, Gary. Everybody, you know, give him a virtual round of applause.
Virtual wave. Huh?
Yeah, virtual wave. You can put your applause in the chat. All right.
The ASL.
Oh yeah, that's good. Very nice. All right. I'm going to go back to sharing my screen for a second. And then if anyone else would like to take a turn with the lightning talk. Oh boy. Sorry about that. That was the timer. If anyone else would like to take a turn with the lightning talk, I think we have time for one more 5-minute lightning talk, up to 5 minutes. I think, Steve, you had volunteered, but
Yeah, I could do one, but I don't need to do it today. If someone else wants to do it, I could do it, you know, future month or something.
Maybe in the interest of time, you can do it.
All right, I'll do it.
Okay.
So I'm going to tell you about a tool that I used that I think is pretty cool. So if you work with SQL Server and you're writing SQL scripts, maybe you have some stored procedures, functions that have logic in them. How do you test that stuff? Well, there's a tool called TSQLT. And yeah, just tsqlt.org, tsqlt.org. And it lets you unit test your T-SQL, which is Microsoft's SQL language. So my company actually uses it, so it's usable. It's on, the code's on GitHub now, looks like. And there's also, if you have a Pluralsight subscription, there's a Pluralsight course called Unit Testing T-SQL Code with TSQLT that I've watched some of, and I hear is pretty good. So if you want to add some unit tests to your T-SQL, check out TSQLT. That's all I got.
That's really cool, Steve. I have a question.
Yeah.
Is it possible to, like, how does it kind of like output results and things? How do you read, like, when your tests are successful and when they fail and everything?
Yeah, so I used it and I wrote a test. So I set up some tables for like expected results.
Mm-hmm.
And then like ran a stored procedure and put the results in an actual results. And then TSQLT has something that lets you compare tables, and then it outputs things in text, and you can see like what parts are different.
That's cool.
Yep. You can also output stuff in XML format, which may be useful if you want to run it during CI.
Yeah. Very cool. Anyone else have questions for Steve on TSQLT? All right. Well, again, if you want to do the ASL version of applause, or you can just tell Steve thanks or give him the thumb. Looks like you can give him the thumb. I don't know how that works, but it sounds great. There we go. Yeah, Zoom. All right. Okay. With that, I think we're done with lightning talks for now. So we're going to move on. Next, we'll go through and we're going to go to our presenter. But first, really quick, a couple of housekeeping items. You can always subscribe to our YouTube channel. You can get to it by this link. It's just a quick bit.ly link with slcnet-yt at the end. And we appreciate all of our subscribers, and you'll get a notification whenever we upload a new video, which is kind of handy. Yeah, we already talked about how to do questions and things. We did our lightning talks. And so now I'm going to introduce Allan Stewart. I'm not going to read what's on here. You're welcome to read it yourself. But I've known Allan for a while because we met at the Utah Software Craftsmanship meetup, which is a great meetup that also meets, I think, on first Wednesdays, I believe, of the month. Am I right about that, Allan?
That is correct.
Yeah, on first Wednesdays, and it's a great meetup, and they do a lot of really cool exercises. I think this one is probably similar to some other cool exercises I've seen there. A lot of participation type of activities, and also they do a monthly book club where they review some things. And anyway, I had the opportunity to meet Allan there. I've seen him present there. I know Steve has as well, and some other folks. And also, you know, just have some discussions about some really interesting books and topics with him. And he's a super sharp guy. So I'm really excited for this presentation today. And with that, I think you can take it away, Allan.
All right. Thank you, Will. I'm going to steal the screen sharing here. Okay. Arrange my Zoom windows so that everything is ready to go. And then I'm going to go ahead and start talking about mob programming and specifically remote mob programming. This is a collaborative way of working that I first was introduced to about 6 or so years ago, and I've really enjoyed it, and I've been advocating it pretty much ever since. So in this talk, I want to just introduce some ideas around what mob programming is, how you can do it with remote teams, and some of the things that make it effective. To start off, before I talk about mob programming specifically, I want to talk a little bit about what work looks like when we aren't collaborating, when we're working solo. Because this is a common state for a lot of developers working in most of the companies that I had worked to prior to discovering mob programming, is that you get to work and you're on a team, and you probably have your stand-up meeting in the morning or something like that, and afterward you just get to your individual tasks. Everybody's farmed out their individual thing that they should be working on, and they go and sit at their desk or their cubicle, or if everybody's working remotely, maybe they quit Zoom and go and do their work. And a day of working solo oftentimes looks something like this. We've got programmer A here who starts their day working on a task. And eventually they get their task done. And so they want to have some form of collaboration. So they'll submit a pull request, typically. And then, being a dutiful employee who wants to maximize the return on investment for the company, what do? Well, they start working on the next available task, which in this case is task 4. And they start writing the code and working their way through that next task. But meanwhile, what are the other people on the team doing? We have developer B trying to work on task 2, but getting stuck. And there's a third developer C who is the person that can help but they're not responding for some reason. Maybe they're in a meeting, maybe they are busy or doing something else. And so B is having some trouble. And what do? They're going to block their task and start working on a pull request instead. Meanwhile, we catch up with developer C. They've been busy. Maybe they were in some meetings or something. Now they're busy finishing up task 3. And they haven't helped B yet. And as the day progresses, eventually they finish task 3 and they get that code merged in. Meanwhile, developer B is still stuck. They moved on, they did the pull request, and now they have to figure out something else that they're going to do. Meanwhile, developer A is submitting another pull request, which does give developer B something to do, but it's also adding additional work onto each other member of the team. Eventually, developer A is start on another task because they're waiting. These other pull requests are in queue, and so they're continuing to work on the next thing that's going on. Our developer C got some help sent off. Maybe it was an email, maybe it was a Slack message, something. They helped developer B get unstuck, and so now they can work on task 2. And as we progress, if developer A is good and paying attention, they'll see that all of their pull requests are done, and they start working on task 1 again. They put task 5 to the side, and they'll find out that there's a merge conflict because task 3 was done earlier, and it caused problems for the thing that they had just been working on with their pull requests and the reviews and things like that. And so throughout the course of the day, these kinds of waiting scenarios happen as the team works primarily individually. They're working solo, but they are attempting to do interactions between them, usually in the form of pull requests or Slack messages and emails and things like that. So let's rewind the day and look at what this same team might accomplish in a mob programming scenario. But first, we should talk about, well, what is mob programming? One of the pioneers in the space, his name's Woody Zuhl, and he talks about mob programming like this. It's getting all of the brilliant minds working together on the same thing at the same time, in the same space, and at the same computer. So we're going to take all our developers, A, B, and C, and put them in front of a big TV where everybody can see the code, and they're going to work on the same computer, and they're going to start off their day working on task 1. Well, task 1 didn't take very long to do, as we saw in the prior example, but it needed some feedback in the form of pull requests. In the mob programming scenario, you don't need a pull request because you have the other developers sitting there alongside, able to give suggestions and make critiques and other things that improve the code and get that feedback loop that we were looking for. And it helps them to understand what was going on in that code as well, which means that they can complete the task very quickly. And so they move on to the next task. Now, task 2 was the one that developer B got stuck on. And they had a kind of a bad day because they were stuck waiting for feedback. And they don't understand how it works. And developer C is the one who can help them. With mob programming, developer C is sitting right there next to them, and they can explain the thing that is tricky, or they can tell them about that piece of the domain that that developer B didn't know for some reason, which means that they can complete the task and get it done. They start on task 3. Again, they're working together, helping each other as they go until the task is done. And by the end of the day, they're able to start on task 4. So let's think about what the differences are in these two different scenarios, and what kind of results did we get? Now, it is somewhat of a contrived example, but it is based on the kinds of experiences that I have seen teams run into multiple times. It's based on the kinds of things I see teams do when they're working solo or when they're working collaboratively. So here's the results. On top are all the things that got done when people were working solo, or got worked on at least. And on the bottom are all the things that were worked on when they were mob programming. It's the same people. It's the same number of slides. I tried to make sure that every task had sort of a same number of slides that it takes to get done, unless they're stuck, unless they're waiting for somebody else to give them feedback. And so one of the first things we notice is that there's a lot more stuff that was going on when the team was working individually. Task 5 and 6 didn't show up at all in the mob programming scenario. And there is at first blush a lot more green. But we look at some of the tasks, or some of the things that were done, some of the things that we track as like individual items for people when they're working solo, and we see that there's a lot of pull requests and there's helping developer B. Well, when the team mobbed, all of those things really happened. And pull requests are a mechanism to establish some collective code ownership, help other people understand the code that you've been writing, and also give them an opportunity to provide feedback. Both of those things happen naturally when people are mob programming. So really, although we didn't track them as separate items, we could say that a bunch of pull requests and the helping of developer B all got done. So it's the same team, the same amount of time, working on the same tasks, but the mob programming team was able to accomplish more. More of their tasks were finished. And we can ask some interesting questions too, like, does it matter if task 3 gets done before task 1? Is there anything important about that sequence? There's no merge conflict in the case of mob programming. And what I've found is that although it doesn't seem like it at first blush, mob programming is incredibly effective. And really what it comes down to is this idea of efficiency. People will ask about, well, how can that be effective? If you've got 3 or 4 developers, maybe 5 or 6 even, that are all staring at the same computer, like they could all be working independently. But working independently causes some other secondary work effects that you don't always observe. Mob programming naturally favors this concept of flow efficiency over resource efficiency. Resource efficiency is the thing that we usually think about when people talk about efficiency. And that's because we live in kind of the Western culture that is the result of a lot of industrial revolution kind of thinking, where everybody should be busy. We get trained in, you should be busy. You should, if you're sitting around not working, well, then that's bad, right? And so you're focused on the worker. You're focused on each individual person and saying, okay, are you busy at all times? Because that's the way that we measure resource efficiency. But flow efficiency is about getting stuff done. It's about monitoring the flow of work from when it gets started until it gets finished. And so mob programming, by focusing on flow efficiency, is able to get more things done in the same amount of time with the same people by putting them together, even if it looks like they're not as busy. So with that example kind of in place and getting people thinking about the efficacy of mob programming. What do you need to know? If you were going to start mob programming, you're going to give it a shot. What would you need to do? The primary thing that I would tell everybody is that there are two roles. There are actually other roles that people have discovered or invented in the mob programming space, but two of them are the most important, and that is the navigator and the driver. A navigator is somebody who is talking about the problem and how we're going to solve it. So they're describing what code is it that we should write? How should we do this? How should we name these variables? How should we go about applying code patterns in order to solve our problem? And the driver is a person who listens and translates those ideas into code. So they're kind of like a smart keyboard. And just like a keyboard, you don't want it to run off doing its own thing. It's important that the driver is listening to what the navigator or navigators are saying and not doing things on their own. Because if they go off on their own, it may seem quicker for them, but it's really hard for the rest of the team to stay engaged with what's going on. Llewellyn Falco calls, he has a thing he calls strong pairing. And that is that for an idea to go from your head into the computer, it must go through someone else's hands. And this is a really powerful technique for any kind of collaborative coding. If you are going to do some pair programming, this is a great way to do it. But when you are doing mob programming, I consider this an essential piece, because this is what keeps the rest of the team engaged, so that they're not drifting off and seeing, you know, somebody pinged me on Slack. Let me just go and answer this email real quick. Oh, while you do that, I'm going to do something else, which is really easy to do. It also means that there's a lot of vocalization going on. People are talking about the code. And that helps with the understanding, so that everyone on the team knows what's going on and is able to share their ideas. As soon as the driver starts typing their own ideas, their brain tends to kind of shut down from the communicate with humans wavelength and move on to a figure out how to type the syntax wavelength, which isn't a very good way to help other people on the team understand. So what does this look like? Oh, there we go. Now we know what it looks like. So this is a photo I took of one of the teams that I used to work with as they were doing mob programming. So there's one person, the driver, sitting at the keyboard, and he's listening to his fellow team members as they're talking about the problem. What kind of test should we write? What patterns are we going to apply to make this work? Hey, have you thought about this scenario? Anything that it is that they're talking about. And he spends some time typing. And when his turn is up, they all rotate, right? Everybody can see what's going on because they've got a couple of big screens there. And he'll just slide back when he's done with his turn, and somebody else will slide up to the keyboard and start programming. With mob programming, I strongly recommend that you use a timer, because you've got a lot of people who are waiting for a turn to be the person at the keyboard. There's something just visceral about typing code that helps you feel an ownership in what's going on and like you are participating. Even though the navigator role is critical, that having a turn at being the driver is really important as well. And so a timer allows you to switch roles and make sure that everybody gets a turn. Normally, I would recommend about 10 minutes, especially if you're working together in person. 5 minutes might be okay for like a code kata or something like that. But what I've observed is that when people are working remotely, a few more minutes is often helpful because the cost of changing from one driver to the next is a little bit more difficult when you're remote. You can't just have one person slide away from the desk and another person slide up. So let's talk about that for a second. What about remote? When Woody Zuhl talked about this, he talked about the people all at the same computer. There's this kind of co-located concept that has formed up around mob programming. Well, I feel like there are three key things that make mob programming work, whether you're remote or co-located. The first is that everybody needs to be able to see what's going on. So that can be accomplished in a few ways. The two teams that I work with right now, they accomplish this through Zoom. So very similar to what we're doing right now on Zoom, with somebody screen sharing, but instead of sharing a slide deck, they're showing their editor, and whoever's the driver will put their code up and everybody can see what's going on. I've also had some good success with tools like Visual Studio's Live Share that gives everybody the opportunity to look at code and interact and see where the other, even though they're not seeing maybe the other person's face, they're seeing their cursor and where they are on the screen. So that's the first thing. Everybody needs to be able to see and observe, understand what's going on. And the second is that they need to be able to talk and be heard. When you have people working together in a mob programming environment, there's a lot of discussion. That's key to the whole thing. So, if you're on Zoom, you've got to get people to come off of mute and talk. You could also do, something else like, a Discord or some other mechanism where people are able to communicate in real time. And the final thing is that everybody needs a turn to edit the code. So using Live Share, that makes it pretty easy. Actually, everybody can type all at the same time if they wanted to in Live Share. That's not very effective. That's a good way to add a lot of confusion. But anybody can just start typing when it's their turn and participate that way. I've also heard of teams and seen it done a little bit where you have a shared machine that everybody remotes into. So for example, it might be a virtual machine that is out in your favorite cloud provider, and you remote desktop in, and the person, oftentimes you can only have one person remote desktoping at a time. So whoever that person is, they also share their screen so that everybody can see. And then they take their turn editing, and when their turn is over, then they let the next person sign in. The way that my two teams are doing it right now, though, is every individual developer on the team is writing code on their own computer rather than having a shared station. And they're using Git as a mechanism to transfer code between each other. So as they get done with their turn, they commit and push all of their changes onto a mobbing branch, which then the next person checks out and continues the work. And to facilitate that, they're using this tool called Mob. I've heard some good things from other people in the mob programming space who also have enjoyed this tool. It is written in Go, I believe, and it basically is a command line utility that makes it easier to create mobbing branches and squash your commits at the end when you're done with a mobbing session. And it's got a timer built into it as well. So you can type something like mob start 10 or mob start 15, and that will start the timer, and it will let you know when it's your time to let the next person go. So I mentioned I've seen mob programming. I was introduced to it about 6 years ago, and I've really liked it because once I saw what was happening with the teams that were doing mob programming, I started noticing a lot of benefits. I'm going to talk about some of those real quick. The first one, and I like all of the benefits, but this may be my favorite one, is that you get really tight feedback loops. When you're writing code, as in a mob programming setting, the other members of your team are right there and able to, you can talk with them in real time and understand how to improve the code that you're working on. This is really important for developers who are new, either newer in their career or newer to the code base, or perhaps new to the team, because they can get feedback right away about what they're doing and why the team behaves in the way that they do. The team gets feedback right away about, do we like these variable names? Or even like what kinds of patterns, or even things as simple as where do we want our braces, and do we use tabs or spaces, and how many spaces? All of those things can get resolved in a really tight loop that lets you move very, very fast. Another benefit is collective code ownership. This is an opportunity for everybody to be engaged in the coding process. One of the problems that I often see with pull requests is that people don't feel a sense of ownership in the same way that they do about the code that they participated in writing. A lot of times with pull requests, the developer will look at it and say, yep, that looks good. Or they'll have some critique about, variable naming or something, but they don't feel that ownership of it. And it can be very difficult to get people to check out that branch, go and look through that code, run it, exercise it, because it's already done. There's a sense that this code is done and it's just under review, which is different. You don't get the same sense of ownership that you do when you're doing mob programming. And if you're only doing pull requests, it can often be the case that you'll hear people say things like, oh yeah, so-and-so wrote this code. We should go talk to them. Another benefit with mob programming is that you consistently create code that has a really high quality, which comes about because of those feedback loops, because of that high ownership. You're able to create code with high quality because everybody's participating. Whether you are having a good day or a bad day of writing code, you've got a whole team there to work together. And so together with your team, if you're making a mistake or you're getting stuck or you're having a problem, then they can help you to improve that code quality. And likewise, you're able to help them when they're having trouble, if they're struggling, or if you know a better way to accomplish the goal that you're setting out. A nice thing about mob programming also means that you don't have to have so many meetings. When everybody worked together in the previous day, there's not a need to come together and ask each other what you did yesterday and what you're going to do today and what your blockers were, because you already know. Everybody worked together. Now, that doesn't mean you won't have stand-up meetings, because you may need to connect up with other people in other disciplines that weren't working together as part of a mob the entire day. But you can make those meetings shorter. It can be more focused on the collaboration across disciplines rather than focusing on each individual person and what they did. when you're writing code as part of a mob, you have a lot of flexibility to just leave without slowing down the rest of the team. Sometimes you have this when you're working solo, but the problem is that when you're stepped away and you're working solo, the other members of the team don't always know that that's the case. They don't know whether you're available or not, and you don't know whether or not they need your help. So if you have to go to a meeting, or you're going to have an early lunch, or something else is happening, when you're mob programming, the work can continue. Nobody's waiting on you because you had checked out that piece of code and you had a task that needed to get done. Maybe your task was to write the code that interacts with the database for the current feature, and everybody else is waiting on that to happen. Those kinds of queuing, like we saw in the examples I gave at the beginning, they happen on a pretty regular basis. When you're mob programming, everybody owns those things together, and so you can step away while the rest of the team takes that on. And finally, speed. It can seem like it's not very fast, especially to an outside observer. But I have observed, when I've looked at the output of teams that are doing mob programming, it is very, very fast. They get a lot of things done very quickly. But like anything, mob programming comes with a set of trade-offs. It's not a perfect good. It's not holding true in all contexts. And there are some drawbacks. The first drawback is really around that perception that some developers in the mob just aren't working hard. There's that perception where your manager comes over and looks and sees one person typing and a couple other people that are sitting around and talking. Are they working hard? Yes. Right. When we look at the concepts from Lean around flow efficiency, we learn that it is very effective. But it's hard to convince people who are still in that industrial revolution kind of mindset about what is effective. And that can be a problem. That can be an issue that can really hurt morale or prevent you from being able to start with mob programming. So to compensate for this drawback, what I usually try to do is show people the output and say, stop looking at the worker. Are we happy with how quickly things are getting done? And a lot of teams track their work in some kind of a ticketing system or cards, like user story cards or something like that. And that gives you an opportunity to experiment and say, okay, we're going to try mob programming. Let's see how many cards get completed. Let's see what the quality is like. How many bug reports do we get back? And look at those numbers rather than look at whether or not it feels like people are busy. Another drawback is that when you're mob programming, it is harder to tell who individually is contributing to the team. And there's a lot of opportunity for somebody who is not currently the driver to kind of clam up and back up, and maybe they get distracted looking at something else on their phone, or oh, sorry, I was looking up some documentation or doing something else and wasn't really participating. Alternatively, it might be that in the group, somebody has a good idea, but they're always deferring to somebody else. Maybe they're deferring to the team lead because they feel like that person has authority or is a more senior developer or something like that, and their ideas might not come out in the same way that they would if you were working solo and they were forced to apply their own thinking into the code directly. This can be mitigated by having the team paying attention, making sure that everybody is participating, and making sure that they stop down to listen to ideas, especially competing ideas, alternate ways that something could be done. And then the third one that I wanted to mention today is that you have to spend time with people. And spending time with people sometimes is emotionally exhausting. Sometimes there are clashing personalities and other issues that come up that are complicated. They're not easy to work around. When you're working solo, you didn't have to sit next to those people. You didn't have to talk to them all day. And a lot of developers got into code not so that they could talk with people, but so that they could work on machines, right? So they could write code and see something happen. Even introverted people do like to spend some time communicating and socializing. And luckily, with mob programming, you're socializing around a task. You're working together with other people, and in a setting that is not a lot of small talk and just kind of general socializing, but it's talking shop. And so that helps mitigate this somewhat, but at the end of the day, it still can be quite exhausting for those people. And you have the same kinds of problems that you sometimes experience in other collaborative zones, like the school project that you worked on, where some people just didn't seem to pull their weight in the same way as the rest of the team. So as I'm getting close to the end here, I'd like you to think about, what does it mean when you say that you're a team? When people work together and they say, we're a team, and they all divide up and work individually, and they're working solo, I feel like I liken that to a bowling team. In bowling, you have bowling teams, but everybody does the same job, all isolated from each other. They're either taking turns, or they might even be on separate lanes, and they're doing the same thing, but they're not really doing it together, right? There's a high degree of isolation. And so sometimes we look on and we see that there's some task that somebody else has taken on, and all we can think to ourselves is, wow, I sure hope that they do a good job with that. Or I'm going to have to clean up that code later. Or please will you help me with my task? So that's my kids bowling. Contrast that with a different type of team sport, like soccer. In soccer, every member of the team is on the field contributing at the same time. Now, how they contribute might be different. And they're not all, even my son's soccer team, they eventually learned that not everybody should be trying to kick the ball at the same time, but they should position themselves on the field. And there's some roles that might be specialized. You've got the goalie back there who hopefully doesn't have to do very much for a lot of the game. Because if the goalie is having to work hard, then that means that your team is struggling at the game. But you want your goalie to be really good, because if you are struggling, they can help you out. Those same kinds of things can show up in a programming team, where you have some people who are really good at certain specialties. And maybe you're not exercising those specialties all the time, but they're able to contribute throughout the entire day that you're working together. So consider, what kind of team do you want to work on? How do you want that collaboration to show up? And are there things that you can experiment with collaborative programming? It might be mob programming, it might be pair programming, which has a lot of similar benefits that could enhance the way that you work. Woody Zool and some others have used this little phrase that I'm going to end with. Mob programming is about getting the best out of your team. You want to get that really high quality code that comes from people owning it together, helping each other out to make the best thing that the team can do, rather than the most. Having the most things worked on in a day isn't necessarily what's going to bring the most business value to your organization. So I think we have a little bit of time if people have questions. If you're not tired of hearing from me, recently I and a couple of my friends have started a podcast. You can learn about that. Or as Will was mentioning at the beginning, I'm a frequent attendee of the Utah Software Craftsmanship group, and you can find them at utahsc.org. So if there are any questions, please feel free to unmute yourself or put it in a chat, and I will do my best to answer.
How do you see the value proposition compared to pair programming?
Oh, that's a great question. So pair programming is also highly collaborative, and it is also a discipline that I quite enjoy. I think that one of the biggest benefits that I see with mob programming over pair programming is how you divide up the team and the work. So if people are doing a lot of pair programming, then you have to figure out the interactions of all the different people. If you have an odd number of people, then that can make it a little bit harder to divide up in the morning and say, okay, who's going to work with whom? Similarly, if somebody has to get up and leave, they're leaving their pair by themselves. Like, sorry, I have to have a meeting now, and then I'm going to be at lunch, and then I'll see you again after lunch. And that may cause a stretch of time where you're not getting the benefit of the pair programming. You've gone back to solo programming. And additionally, if you have, let's say, 2 or even 3 pairs on a team, each pair is going to have a way to merge their code back together with the main line, with the rest of the team eventually. And so you get fewer problems as far as things like merge conflicts and queuing between individuals. You get fewer problems with pairing than you do with solo. But those are some of the areas where I feel mob programming excels while having a lot of the same benefits with pairing.
How about a breakdown of time spent? Do you find that teams are most effective when they mob all the time, or is there some kind of ratio where some amount of pairing, some amount of solo, some amount of mobbing? Like, what's the best balance there?
Most of the teams that I've worked with, once they've done mob programming for a little while, because it is a skill, same with pairing, there's a social skill that you have to learn so that you can get good enough at it that you can do it effectively. Most of those teams, I've found them to just want to do mob programming all the time. That's just kind of their go-to way of working. But I've also worked with teams where they'll do mob programming strategically. They'll say, hey, we're about to start on a new project, or we're going to, create a new thing, a new deployable, a new microservice or something like that. And so we're going to mob for a week so that everybody understands this new thing really well. And then we're going to go back to pairing or working solo. I've also seen people who want to, they just want some space. They want to either be able to step away and write code by themselves, or maybe it's just a little bit too exhausting for them to be mobbing the whole day. And so I think as long as you can work with your team and come up with a strategy that makes sense, then that can be great. You know, maybe you decide, hey, we're going to mob every morning between stand up and lunch, and then after that, we'll break up and do individual work. If that works for the team, then by all means, I would be okay with that.
Is there a right team size for mobbing, or does it get too big, or do you find that the team has to split the two mobs at some point when they're too big?
4 developers seems to be about the sweet spot for me. It depends on the individuals, but 4 or 5 people is pretty good. 3 is okay, but when somebody goes away, then you're pairing again, and so you kind of break down that mobbing. Somebody's going to be on vacation, and somebody else has a meeting, and so now you're solo again. But with 4 or 5 people, works really well. When you have more than that, it can be difficult because it takes a while for everybody to get their turn. And it's really easy for people to get disengaged. But like you mentioned, you can split off and have maybe 4 people working in the mob and 2 people working on some other task, kind of, you know, maybe doing some research or something else that's moving you ahead. I see there's a couple questions in the chat. Are your experiences with mob programming with programmers of similar experience level, say all senior for some definition of senior? How do you balance participation with mob with a wide variety of experience? This is one of the things that actually drew me to mob programming. The first team that I was on was pretty highly experienced, I would say, and that was really fun for me. When I started on my first team that did mob programming, they were all well experienced, and that helped me understand the company and the problems and things really fast, and be able to get going much quicker than any other job that I had been in. And then eventually, over time, the team shifted, and we had some more junior developers, right? And to the question, right, what does senior developer and junior developer even mean? But let's say in this case it was somebody who was pretty much just out of school. I think they had one job that had lasted a year before they joined our team, and so they were very new to software development in general, and that gave them a lot of opportunities to ask from more experienced developers questions and learn a lot. Probably the biggest downside that I've seen with somebody who has less experience is that they need that time to actually work on some code by themselves in order to be able to do learning. So what our teams do right now is that they have some dedicated time where people are able to work on separate individual projects, some code katas or some other opportunities for learning, so that they can get that kind of visceral, I was coding this by myself, I made the decisions myself, and I get to deal with the ramifications myself. Let's see, Gary put in the chat that regarding the size of the mob, that with larger groups, then you want to have faster rotations. I'd agree with that. I'd agree with his comment there. There was another question in the chat about disagreements. There's a few ways that you can deal with disagreements in a mob, but the thing that I want to lead with with this question is that the disagreements are there with pretty much any kind of team. No matter how you work, there's going to be disagreements. when you're working in a mob programming setting, those disagreements just happen to come up to the forefront a lot sooner. It's a lot harder to be passive aggressive and I'm going to change all the tabs into spaces in the next commit, and then the commit after that, they're going to change it back from spaces to tabs again. And so you have to kind of, you have to work it out. There are some clashing personalities where maybe you just can't actually mob program effectively with some people. But if everybody is willing to kind of put their ego in check and say, hey, we might not agree on how we're going to do certain things, but some things we can just decide on. Let's pick tabs or spaces and be done with it and move on, because that doesn't really matter. Other kinds of disagreements, like you might have two different ideas of how you want to tackle a particular problem. Talk about it. Talk about it amongst the team and see if you can come to a resolution. And if you can't, what I've seen be really effective is just take some time, time box it for like an hour or two and say, we're going to try solution A first, and we're going to do it for a little while. And then we're going to try solution B, and we're going to compare them. And we're not going to take too much time, hence the time box, so that you can look at both. And usually that is enough to get through a lot of disagreements.
One thing that I've heard from Woody Zuhl about disagreements, like you've got two different approaches. He suggested trying the more junior person's approach first. And then, maybe if it doesn't work, then go with the other person's approach.
Yeah, I really like that. There's one more question in the chat. So feel free, if you have any others, you can throw them in. We're almost at time, but how can you use mob programming to train either new members of the team, unfamiliar with the code base, or more junior programmers? It was similar to the previous question, but just to kind of reiterate, what I've seen a lot of times happen in jobs that I was at before is, like, I would start on a new job and I didn't know anything. And they would say, okay, here's your computer, here's your cubicle, sit down and write code. It's like, oh, I don't know anything about this business. I don't know anything about this code base. And so what do you tend to get told are things like, oh, well, maybe just read some code for a while. As if that was an effective way to build up an understanding of the context of the business. It can be useful to a degree, but it has very quickly diminishing returns. And so I would get up to speed a lot by myself. And then when the new person would come, I would tell them probably the same useless thing. Well, why don't you just go and look at the code for a little while? When you're mob programming, that switches, and you say, come sit down with us and see what's going on. One of my favorite things to do is to take someone new and say, oh, good, you don't know what's going on, sit at the keyboard. Because that way, all the people who do know what's going on can tell you, can explain the problem and help you know what to do. If they're a more junior developer, you might spiral into a few questions of things like, oh, well, what is a Lambda expression? And how do I attach a delegate to this? And you can have those discussions in real time, and you can tell them what it is that they need to do. And when they're doing that, they're doing it hands-on, and they learn very quickly. Okay, I think we'll finish with the last question from John Turner. There is a link and maybe John has the link. At my company, I work for a company called Immersion, and we have a guest mobber program. So if you have not done mob programming before, and you would like to try it, then you can come and spend an afternoon or a morning working with one of our teams and try out mob programming. So maybe Will, I'll have to get you that link here shortly.
Yeah.
But with that, I'm going to go ahead and stop my screen sharing, and thank you all for listening.
I just, if I could, I just wanted to share just for a second a bit about new people. Because I work for a large organization that is not particularly good at onboarding people. So a lot of times our new people will spend the first 2 weeks with a loaner laptop and a develop environment that's not set up. And we've discovered that having a culture of mobbing and pairing means that any new person is committing to the code base their first day. They're into the code base, they write code, they've committed code the first day, and that's had a tremendous impact on how successful people feel very quickly on our teams.
Very cool.
Yeah, that's a great comment. I've seen the same thing as well.
Thanks, Gary. All right, it looks like that link made its way into the chat. So if you are interested in signing up to become a guest mobber with Immersion, you can pick that link up and sign up. And with that, I want to do a really quick, first off, thank you so much, Allan, for coming and for regaling us with tales of mob programming remotely. Everybody, if you want to hit one of those response icons in the chat, or not in the chat, or wherever, just make sure and let him know. We appreciate it. So thank you so much. The next thing I wanted to do is really quickly just thank our sponsors. We have a few sponsors for this group. Some of them provide prizes. Some of them, when we meet in person, provide locations, food, things like that. So thank you to all of them. And then I'm going to move on to the next screen, but I think this is the point where we stop the stream. So I'll say goodbye to our friends on YouTube. Thanks for joining us.